Right, amazing. Suppose we're live. Right, so let's do a quick little recap. So the past so many streams we've been working on procedural materials, or a procedural material, which is we start off with a brick one, and I've sort of changed this just a little bit, such that we can visualize the problems a little bit more, or just have a better test scene. So we've got one super big brick one and then two smaller ones, but they're twisted to the side. So the one of the main issues was bumping into last stream, or when we finished it up, was the performance of this was looking at about 2 milliseconds for a resolution something like this. With more stuff on it, it's about 3.2 milliseconds. So it's quite expensive to Raymarch a cube procedurally, as you're seeing, and get a sort of brick surface like this. Hey there, Buffer. How you doing? Yeah, no, I'm a good man. How are you? Yeah, it's my birthday Friday, so yeah, had a barbecue Saturday, so it's been really cool. But yeah, not bad, bit tired, but that's about it. How about you? So this like brick, procedural, procedural brick material that we're sort of ray marching into. It's all done in shader code, but it's just a little bit expensive, and that's a lot of the time because of these near miss pixels here, right? These ones which keep ray marching through and then they miss. And you can see there's something wrong with the it looks a little bit odd, like these bricks should be sticking out more and these ones are sticking out too much and bending that way, and these ones sort of curve a bit where they shouldn't. So there's something to do with I haven't tested it on a non-identity matrix transform, so now that we've transformed it from world now that we've rotated these cubes using transforms, it's misbehaving, but that bug is not going to get in the way of today. So we'll solve that in some future stream. But today we're doing order independent transparency. And the reason is we want to make this perform better. So currently we have a visibility buffer. What that looks like is something like, hang on, this one. This is what it looks like. So as you can tell, it's a U32 and it's got it has a instance index and a triangle index packed in, so you can sort of make out these two cubes. I'm not sure how much that's going to help, but yeah, and then there's a cube at the back. Now I could probably make a better viewing mode to view this properly, but anyway, it doesn't matter. So what we basically want to be able to do is make it such that we could try and Raymarch these things at lower resolutions, but we can't do that. Sorry, yes, we have this buffer, and then we read this buffer from the scene shade, and then shade the pixels by doing a Raymarch, doing the procedural material. Okay, so we want to do it at a low resolution and Raymarch most of the way, and then only Raymarch on small amounts at higher resolutions, right? So there's less pixels doing the same sorts of steps in the Raymarcher, basically. We can do it like maybe a quarter resolution and a half resolution, maybe even as low as an eighth of the resolution. So this would heavily, should help with performance quite a bit and help bring some of these numbers down, right? And we're hoping for around 4 milliseconds at scene shade. So the reason why we're doing order independence transparency is because you notice that when we have a cube here that goes on top of another cube, if you miss in the Raymarcher, you can't get the pixels behind because we've just rendered a visibility buffer and we've lost the information which is behind, right? So what we need to do is add a layered visibility buffer. Basically, that's the plan for today's stream, and that is in turn going to get us order independent transparency. and then we can use that to do this sort of like in the future we'll do a cone. I think it's called a cone tracer. You just well, science distance field is cone tracing, but yeah, you're doing like a smaller resolution cone tracing and step most of the way in a lower resolution, and then do s- le- less steps in higher resolutions, basically, and that'll be the plan. So, yeah, any questions? Feel free to ask away. Awesome, good to hear, Buffer. Hey there, Alexa. Welcome, welcome. Evening, evening. Yeah, since last stream, I basically just made this test scene, so there's not really much that you've missed. If it looks a bit different. Yeah. Got myself a nice warm tea. Right. So today's actually quite exciting because we're going to try and use an extension that I've not used before. So basically, to pull off order independence transparency, what we want to do in the visibility buffer render, we probably want to rename this. So it used to be dead simple. I don't know if I want to do the spheres anymore. I should probably get rid of that code. Yeah, it's just hacky code. But yeah, we basically just want to have a structure. We just want to call it like pixel or layer. Yes, you have a layer, and this will just be a U32, and that's going to store inside of the layer the mesh instance, index, and the. You know what? We should do this in the So I got my custom language, my custom serialization code generation thing, so we can get all the packing written really nicely. So graphics VK, layer buffer layer, we'll call it. So a layer just looks basically as a U32 16 bits. You have a mesh instance index. We'll have a mesh triangle index, and then a float 32 depth. Now, yeah, something like that, I think. And then when you write out your buffer pixel, we'll call it, and the buffer pixel is just going to be an array of 4 layers. Now the plan is in the pixel shader, or the fragment shader, is to write out this custom format, and obviously that doesn't store inside of a texture. So this is like 8 bytes, right? Yeah. And so if you have 8 times 4 is 32 bytes, right? Is that right? I think so. Yeah. So yeah, because I was thinking in bits earlier, that's why. So then times 4 is 128 bits. Yeah, so it's quite fat, but it'll be fine. So we're just going to have an array of these guys, and rather than run out to a texture, we're going to write it to a storage buffer. And yeah, it's a bit weird and different, but it means we can do order independent transparency, and it helps us solve this problem, this expensive shading problem at the same time. So solves 2 problems and not 1. Now, how could you possibly write to a storage buffer and not get race conditions? So basically, you can do it with atomics and do some atomic swaps, or you could do it with this extension where it basically has a mutex lock in the fragment shader for that pixel. We're going to give this a go. Requires an extension, but we can always write it in software if it doesn't have it. But all hardware that I looked at that I want to support supports it. So we're going to use the extension because it offers the hardware vendors to make the best version for their hardware. So yeah. You've been watching through the Handmade Hero series, and I've gotten excited to learn about maths. Sorry, I had to pluralize that. No, I had to English it. I've enjoyed back in school and university days of actually. Yeah, she had some application. Yeah, that's the thing, isn't it? When you learn some of the game dev stuff, you're like, wow, trigonometry actually can be used in real life. Yeah, it's fun. You know, if only they gave you like, if only they gave you a simple like 2D scene and then a way to write code to like see how this stuff could be used for something, you know? It would have really made people excited about maths. Looking forward to bringing back my joy from both worlds of maths and programming. Awesome. That being said, I'm basically about to do switching from programming to programming. I'm happy to find this path. Incredible. I'm glad to hear your story. Yeah, that's cool. Awesome. How long have you been programming for by any chance? 11 years, cool. Yeah, so you got quite a lot of experience, right? Nice. What languages you been programming in so far? Mostly web dev. Yeah, I see. Yeah, that's where I started as well. Well, yeah, that's where I started, and then I basically just got sucked into as a career path, and I was trying to get out for a long time. But yeah, took lots of prayer and fasting. But yeah, got offered my first job in the industry, and I still have it. It's amazing. It's amazing. So we basically wanna go into graphics VK shared, this header file. Now I want to find a way to make the descriptor. This is our boy. The descriptor buffer ID so we can have it accessible via bindless. Oh yeah. Now, let's completely make our code not compile. That probably sounds like a sensible idea. Let's do it. Let's go all in. Bum, 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 bum. Yeah, you get to see, that's awesome. Yeah, C is the way to go. When you see, you see. I've got to get the robot to do it. There we go. You can trigger it quite good. You just gotta use other languages and it's just like, no. When you see, you see. No Rust. Rust is okay for people who are coming down from web. Helps people come down, but the problem with Rust is people can get comfortable in their cargo, you know? They're like, oh, this package looks nice. Oh, this package. Before you know it, you've got like 100 to 200 dependencies. When you could have just had a little bit of code in your own executable, you know? Yeah, doesn't need to work. I think it's because it's already been triggered once. So it has a bit of a cooldown, so it's not super spammy. Ah. Yeah. So we're going to call it mesh render layer buffer. I can call it LB or order independent. Yeah. I'm going to call it a layer buffer, so LB. It's just my name for it. I don't know if it's got a name, but you know, it could be called a layered visibility buffer. LVB. That better not mean something else. That's good. Right. Yeah, we call it a layer buffer in code though. So I'm just going to call it an LB. All right. Let's go to the build script. Let's just do the super silly thing, which I've not programmed my way out of yet. So we just keep programming our way more and more into this, which is fine. Can be solved later on. Future Henry's problem. Future Henry loves past Henry. But there we go. Okay, so now render LB. Um, Where is this thing even declared? Ah. And we also need the pixels to write out to, yeah? Hang on. Yeah, so read, write, mesh, hang on. Oh, it's there. Layer buffer. LB layer buffer. Lovely. Now, yes, this is the vertex shader. Nothing like that changes. Layer buffer fragment shader. Now, this is where the fun begins. I'm thinking about getting rid of the spheres thing. I don't know. It's kind of helpful at the moment, but after we've got materials basically working and done a few, we should probably just move over to doing meshes right away, to be honest. Yeah, maybe we should just do meshes right away after just doing one. Yeah, screw it. I can't be bothered with this code. Less code, the better. Hey, Davros. Hey, how's it going? Look into Odin, Call Me More Jar isn't released. Yeah, yeah. But that's after C, of course. I mean, alongside, anyways. In technical debt, we trust. Yeah. Yep. Although Rust project seems to encourage learning on leaning on dependencies. Yeah, it's good at managing them. More pleasant than the situation with Python. Yeah, yeah, yeah. Yeah, that's the point I was making earlier. Is with Rust. It's like it's a great like modern implementation of some systems programming language in a way, right? It's basically the C++ that C++ people wanted, right? They hate C, but they want all of that, those move semantics and stuff like that. And Rust does a really good job at that. It's not really my thing, but I did program Rust for a long time, for like 4 years, right? When it sort of before it was a 1.0, I programmed in it, and then after a little bit. Yeah, you're right. People do lean on the dependencies, and if they don't go in and look at the source code of things and realize, hang on a minute, all I need is 20, 50 lines of code, right? Something like that. I can just grab that in. Then they wouldn't be pulling in 200 dependencies, right? If they just kept that mindset going, then they would be in a reasonable place. Right, so we want to try with this extension. I hope my hardware supports it. If not, we'll be doing it manually. So we want to have one of these guys up here. We could probably, if then it puts it in every shader. Let's just put it here. Right, so pixel interlocked unordered extension. So because we do the unordered version and not the ordered version, we have to do these begin interlocked and end interlocked, basically, yeah. So we're not going to have a visibility buffer out. Instead, we're going to have a... Oh, I need to get the input depth as well. Is it GL depth? Right, how'd you get the depth? Ask AI because it'll be easier. GLSL depth, get depth in fragment shader. Is it GL depth? Okay, frag chord Z. Yeah, oh, that's a terrible idea. Do not do that one. Oh, it's a horrible idea. Right, problem solved. Now, so we want to get the layer. So we've now locked, and that locks the pixel. So another pixel triangle will be rendering here. So we can do the whole buffer read only graphics vk layer buffer pixel layer buffer. Then want to read out the pixel. So we're just going to try it in row major order, right? So classical, the way you saw an image, right? Left to right, and then going down the rows, each row. So we could try and swizzle it. I don't know how much better that would do, because the pixels are, they're 128 bits, right? They're 32 bytes. So maybe you don't get that many good wins. Maybe. We'll see. So basically we want to work out our pixel coordinate. So our pixel index. So I guess that's GL frag coord X. Right. How about it's frag coord XY, isn't it? But that'll be at 0.5. You turn it into an int. So you do GL frag coord. Turn that into a U32. That rounds it. You might round it up though. Do you want to floor it? And then TDY times your width. You probably need that passed in. Yeah, the render target width. Then plus your X, something like that. Now, with this sort of layer, keep it there for one thing I found that I have been having an advanced easy way as most. Blown up with code. Yeah, that's the thing about it. When you start with dependencies, you basically just duct tape in this dependency to that dependency, and all you know is the bridge code. That's true, and not know how it actually works under the hood. Yep, exactly. Yeah, write it yourself, or look at how other libraries do it and copy it, basically, or do something similar, right? Inspired. Agreed. Right, just mess around with the local AI. I like the project's built on GGML, but had to go with the other Python inference engines, which have some platform-specific ops that have yet to regularly write, hence all dependency hell. All that Python. AI and Python. This program only works on Python between specific min and max version. Oh wow. Ugh, horrible. You can imagine that. Hey there, Narsing. You building a 3D flood simulation. Nice. Using Qt OpenGL. We rendered the terrain from DEM data. Cool. Place satellite textures on top. Want to ask how I can improve the terrain rendering quality, make it look more smooth and realistic without adding heavy stuff like shadows or more complex LED systems, right? Mm. Not really sure, to be honest. Um, you know, right, improve the quality of the terrain. You probably would need some kind of shadowing, right? Some degree. Um, yeah, you can run some quick tests to see if more resolution would help. It would be really slow, but you can see if just simply adding more resolution is going to help or not. And then that will tell you if lodding is going to help, how well that's going to help. Um, I'm not really sure, to be honest. Sorry about that. So I can read the whole pixel out and operate on those, or I could... Yeah, so I think the basic idea, right, is you have your depth, and you want to have your new sort of like packed this thing here. Basically, you'd do that, right? So, yeah, you have your layer index. Oh, your instance index here. What triangle? What was my triangle index before? Hang on. Right, I didn't output a triangle index. Oh no, I did. Sorry, the IB is the whole thing. Sorry, the VB. Okay, cool. So, right, you call this the let's call it ID. Right, so basically you've got 4 pixels, oh sorry, 4 layers, and they should be sorted. You want them sorted front to back. So we should be able to basically iterate from the last pixel and go. So as soon as we find one where this depth is less than, I wonder. Yeah, so you're gonna have an array of four layers, and you want to store in an instance index and a triangle index. And so we could say iterate. You could iterate from the front to the back, and if your depth is less than the one at the front, it obviously goes in the front one, but you have to then shift up the rest, right? Whereas if you went from the, I'm not sure which way you could. Yeah, it might be better just to read them all in, because you'd have to do the shifting, right? So you want to sort of like read them in, shift them around, then put them all back. But yeah, that's a lot of writing. I wonder. So if you iterate from the back and you test it if the depth, your new depth is less than depth you've just looked at. You wouldn't necessarily insert it there though, but you could pick it up. What could you do? I wonder if there's a thing you could do. Yeah, so I wonder if you can iterate backwards, basically. So you do like a 4 in I equal 4, I less than... Hang a minute, you got to do that silly thing, isn't it? So that isn't it. Do you have that in GLSO? I'm not sure. But anyway, we'll see. Anyway, so that's a reverse loop. So you basically want to be able to read from this guy. You can call this the layer. So dot layers layer depth. You call this the layer depth. Yes, I think what we'd probably like to do is just put this in a nice little macro, because we'll probably do this a few times. And GLSL doesn't have a way to do pointers without extensions, I think. Actually, no, it does. Yeah, you have like U64. But anyway, it's weird. Still weird syntax. So we'll just call this like, layer. Or layer. Read layer. Okay. So layer index, and then probably some kind of expression. No. That'd be fine like that. Ooh. Alright, so we'll just do this. Right, you probably don't want to read... Anyway, we'll just call it layer buffer. We'll just call it a layer. Or read write layer. There we go. Right. So you read the layer depth. Now, if the current depth is less than the layer depth, then it must mean that this layer has to be shifted to the right by 1, right? Because you're going to have to insert it in at some point, right? So shift right, basically. And if you're at the end, you're shifted out of existence, right? You're outside the array. Now, what else could we do? So then if the layer depth is now not less than, it means that you basically stop iterating, right? Is that right? Yeah, but then you want to insert it, right? So you want to stop, if you're not less than, you want to insert it at the pixel you came from last. So yeah, I think that's what you want to do. Yes, that's probably better than reading all the things in, I would think. So read in the layer depth, shift it right by 1. Yeah, so we should actually start on layer 3. Yeah, start on layer 3. Hang on. What do we do? Yeah, so the first test should be done layer 4, right? It's the last layer. We should probably constant expression this, right? Yeah, by constant expression, I mean in my little custom thing, add constants. So I just went for the word constant expression. So we want like a graphics VK layer, layers count, or capacity 4. The layer buffer. Super long. Just to put a 4 in there instead. Oh well. So yeah, well in the last layer, there's actually a 3. And then we want to start this on there. So if depth is less than or is greater than or equal to that depth that's already in the buffer, then we might as well discard the pixel, right? I'm not sure how it works with this sort of this interlocked thing, right? Are you supposed to do this? Might be a good question. Let's see if no, the AI could probably get this wrong because I don't know how well used this extension is, but do you need to call this if you discard? Something like that. Yes, you must ensure every begin has a matching end, even if you use discard. Okay. Right, so let's do that then. Cool. So now we're going to start from early check the final layer. Now check the rest of the layers. Now because we're checking the rest of the layers, we want to shift. If we pass, we shift right and then continue. So that'll be so shift right would be a layer plus 1 is equal to a layer to the current layer. Something like that. And then if you end up encountering one, you want to say right into the current layer the new depth, basically, isn't it? Depth equal depth, and there'll be a word. I think we call like a bit filled word. I think we call it. I forget. No, it's not it. Bit word. I'll call it bit word. Bit filled 0 maybe. Yeah, these are them. Bit filled 0, which will then be the ID which we passed in, which is just the instance index and the triangle index. Lovely. Cool. So I'm happy with that. Now, so maybe we can put this in another structure. And we'll just call this sort of like a a triangle instance reference, maybe? There's something like that. And that will just go. Or you can call it triangle an instance ref. Okay. Yeah, that'll do. Cool. So that way we can pass this. It's just a U32, so it'll be known as an instance ref instead. And then that will simply just go in. Yeah, instance ref dot. Lovely. So I think this. All right, let's get rid of the output buffer there. Oh, hang on a minute, that's on an out. Whoops, that should be an in. In. So one problem with this sort of new solution that we're doing is the texture view that we've written is not going to work with this, which is a shame. But yeah. So because it only works with textures and not buffers. Real big shame. We could probably make it work, but it again requires more code. It would be cool though. But yeah. You would basically, maybe it won't be that bad. You could say, right, I've got this buffer. But then you don't really know the format of the buffer, but I guess we can add custom ways to interpret the buffer maybe. Maybe through code. I don't know. But it would be great. It might be quite useful actually. Yeah, maybe we can look into investing time into that. Because it would be great maybe in the texture view to like see the layers and stuff like that. Yeah, I think so. Yeah, it's gonna be useful. We should invest time into that. So output instance ref, we'll call it. Okay, so where's the instance ref here? So graphics VK 1 is our guy. So we'll just call it the instance ref. Effectively, we just want to do a graphics VK triangle instance ref instance index. Is code generated, right? So just got to figure out what it's called. I think that'll be it. Set instance ref and then the GL instance index. So that'll store that in there. Then triangle index. That's triangle ID. Typical triangle ID instead. Cool. So then we will basically extract out the bit field. So it's that bit field 0, and that will be passed from vertex shader into fragment shader. Lovely. So with that change now, what we're going to do is change the scene shade such that the scene shade just looks at the top pixel and uses that. And then we can wire everything in, turn on the extension in Vulkan, and we can, allocate the buffers, right? Pass it all into the right place, right? And get it running again. And then I think we'll do the texture viewer because that will be pretty nice to be able to debug view it. It's going to be helpful not just for this time, but in the future if there's any problems. Is that thing rendering here? Or what values are coming in? Can I see those? Right, so I think that would be quite handy. So, where are we going again? Oh yeah, scene shade. So, yeah, I want to get rid of this spheres thing. Screw it. Okay, goodbye. Border box. Why did I need that again? Yeah, I guess so. Right. So this instance index thing. Right, it's just called shade.pc. Maybe we should change that name as well. Call it scene shade. I don't know, but right. So the visibility buffer image. So here we'll call it this will be a buffer this time. So a buffer ID, and it's a read-only version of the graphics VK layer buffer pixel, and so we'll call that the layer buffer. And we effectively just want to read, maybe let's read the full thing in, layer buffer pixel, and then just get the first of it all out there. So do we need depth? Do we need depth? Yeah, we'll need the depth. So let's just read it all out. Layer buffer pixel, call it pixel. And we'll do the whole thing that we did in the previous thing. So it'll be, so like one of these guys, but we could just get it away with it once. So layer buffer pixel, layer buffer. You need to work out your pixel index again. Sort that out. Something like that. So it's pc dims .x, and this would be ucoord. All right. So we're getting all the layers out. Lovely. And then raw, we'll just change that to pixel layers 0 dot. What was it called again? Oh yeah, instance ref. So I guess this is called a, hang on. Instance reference, so the triangle instance reference. So right. So go back to the layer buffer vertex shader. Just nick these guys. And it's just instance ref. You're just reading it basically, right? So you get rid of the sets. It's gonna take 1. Dot bit field 0. Yeah, so if it's not a null pixel, then we have something here. And we can just go and do the material shading, right? Now we have multiple layers, right? We want to try and get that working as soon as. But it's more important if we can debug what's in the layers first. We'll come back to this, but this should get the layer, this is basically, it's all standard code because we don't have a proper mesh system yet. That this will come after. So you've got material shadings, you set up the shading structure, pass in a whole bunch of stuff. Say, hey, make me a surface color. It does all the procedural brick ray marching stuff, and yeah. And then if we miss, we basically sample the sky and use that. And store it back out. Right, so that's all good. Now I want to go into GPU Vulkan. And we want to sort out we want to use this lovely extension. Right, so I don't think I need, yeah, let's just ask the AI just to give us the hints of where we need to put this stuff. So we need to go into the extensions, that's for sure, of the Vulkan device. So that's the instance. Right, here we go. So we've got this stuff as well, so we'll just drop that in there. So that one obviously goes in here, I think. Then, yeah, it's device extensions, nice. We need to add the features, so you got to do these horrible structures, right? It's just so many comments, right? One of the number one things you can tell if someone's used AI is if it's got comments, they used AI. Right? No one writes so many comments around their code, really. Because it'll be so damn hard to maintain. Right. On the create info, of course, you want it there. So here's all my features. Right. Lovely. Lovely. Right. Oh, it's horrible. Oh. Fragment, shader. Let's just go all in. Interlock features. Lock A. No way. Enable. Oh, this comment is so helpful. Anyway. What other stuff does it have? So, right, it says sample interlocked as well. Wow. And there's shading rate interlocked. Okay. I don't know what those do, but they sound sort of familiar. But device features too, already got that somewhere else. And okay, so it's just the P next chain of things. So that would just be into here like so. And this can be like, all right, P next equal null for the next time. Right, so any other things that we need? Verification. Yeah, I need to improve my code. Right now I've just got required stuff, and if something fails, it will probably just error in some weird way. We probably want to be like, oh, your thing doesn't support this thing. Right, so I think we just chuck it into the device create. Really, you want to query it, check all the stuff exists, and then let the user know. But for now, we don't do that. All right, so we're in a good place. So that's all in there. Next thing is we go to graphics VK internal. We're going to get rid of the visibility buffer scene visibility buffer image. We're going to now call it the scene layer buffer. Wow, incredible. So temporary allocate. Oh. So just the size. That's what I like to see. So the size is going to be scene dims dot y. Yeah, dot x times y. So I guess we can do the product elements u32 times 2. Then we simply just times it by size of graphics VK layer buffer pixel. Yeah, we get rid of all that. Nice. And we simply just oh, excuse me. Right. Hey there, Broad. Has this always been a Christian dev channel? Happy to see you're a fellow Christian, but never realized. Yeah, so recently I came back in February and I dedicated it to God. I think it was February 1st. But before then, I would always have been a Christian. I took a break around summertime because I really was becoming from that point probably properly like a born again Christian. So I've been a Christian before then, but lukewarm. I was going to church. My wife was Christian as well, but um, I was doing lots of praying and fasting, drawing closer to God, and then I got given like a mission and the things to do. So I sort of put my stream on a pause. And sort of start reorientating my life properly around God, because it says in Matthew 6 verse 33, but first seek the kingdom of God and His righteousness, then all these things will be added onto you. And that's when Jesus is saying, see the birds in the sky, they'll get looked after by God. And they're worth less than a human being. So if God looks after the birds, He'll definitely look after you. So we have our priorities all in the wrong way. We always go, oh, I'll just sort my life first, and then I'll seek after God, right? So I was in that sort of like mode where I'm like, yeah, my priorities are all in the wrong way around. So I was just, I took a break from streaming and reorientate myself around God. Start reading my Bible a lot more, drawing closer and figuring out, and following the mission that He sent me to do. Basically, was evangelism and letting people know that He's coming back soon. Because yeah, not many people are going to get saved, unfortunately, but there will be people who will get saved. So yeah, it's been very successful. There's been people who've been saved, and also my wife comes out and evangelizes with me now. And it's always been her thing and her calling, and it's amazing. So we go out and evangelize, and I tell you sometimes, or it's basically every time we finish, we catch each other up on all these things that went on. There's so many like little interactions that happen. And, yeah, it's really fun. Yeah. How long have you been a Christian for? Similar path to mine, easily get distracted by the world. If God is all you have, it's all you need. Exactly. That's the pinnacle of John. Well, one of the things illustrated by in John 6, isn't it? John 6, Jesus says, "I'm the bread of life. Whoever you know eats of this bread will never hunger nor thirst." Right. So the basic idea is Jesus will satisfy your every need. Right. So you might be trying to become the very best person at running, become the very best programmer, whatever it is, right? Become the very best man out there or whatever, right? And you have this constant yearn and hunger for becoming the best, but inevitably you'll fall short. Or you think if I can just get this job, it'll make me happy. Or you can think if I just get this wife, it'll make me happy. But after a little while, it won't. And what it's basically saying in John 6 is like, when you have Jesus, like everything's just satisfied. It doesn't mean obviously those things that you won't still aspire to do those things that you want in life, but there'll be a new purpose now. Like it will be to glorify God. And yeah, your joy would be everlasting, right? You just center yourself around God again. You started studying scripture more as a curious atheist about 5 years ago. Uh I would say I converted now. I'm just trying to figure out how to stay in the narrow path. Well, hey there, Browsing. Welcome. How are you? Okay, fair play. You're Muslim. But yeah, it's good to have you here. God bless you either way. I hope you find the truth, the way, the truth, the life, which is Jesus Christ. But amazing. Um, Thank you. Appreciate it. I'm glad you're here as well. Um, so that's the thing, right? With the short and narrow path, right? Here's the Bible verses for this. So Jesus said, enter by the narrow gate, for wide is the gate and broad is the way which leads to destruction, and there are many who go by it. Enter by, many go, enter by the narrow gate, for narrow is the gate and difficult is the way which leads to life, and there are few who find it. That's the one. So we all by default got on this wide and narrow gate. Well, we're following the world, right? We're sheep of the world. We're following whatever everyone else tells us. We're trying to impress everyone else, and you know, fit in with everyone else, and that's the world. That's the wide path that leads to destruction. Then Jesus also said, "I am the door. If anyone enters by me, he will be saved. He'll go in and out and find pasture." And then the final piece of this puzzle is Jesus says, "I am the way, the truth, and the life, and no one comes to the Father except through me." So if you piece it all together, the narrow path is Jesus. Right? It is as simple as that, right? He is the door. He's the narrow path. So the reason why most people go down wide, the wide path which leads to destruction is because they're not going down the path to Jesus, and that's basically it, right? So people want to say all religions are the same, blah 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 blah, but Jesus makes it pretty clear that it's exclusively through Him. So if you know if all religions lead to the right thing, then why does Jesus say, uh, I am the way, the truth, and the life? So, and that's how you become, and that's what Christianity is about, right? It's you're righteous by faith, because by faith you believe in God, believe what Jesus has done, and you don't want to upset Jesus, considering what He's done. He's laid down His life. He's the shepherd, right? The good shepherd, who's laid down His life for your life eternally, and given you a glorified, reserved for you a glorified body um, at the resurrection. His blood, He suffered, lived the perfect life that you could never live, saw you suffering in your sins. John 3:16, right? For God so loved the world, He gave His only begotten Son, that whoever believes in Him has everlasting life and shall not perish, something like that. And it says something after that, like, you know, Jesus didn't come to condemn the world because the world was already condemned. So He came out of love. because we were already condemned and came to save us on a rescue mission. And yeah. So by faith in Jesus is accounted for righteousness in Christianity. And it is true because you become a born again Christian and you just, those sins, sinful desires just drop off. You'll still sin if you've got those bad habits, right? You've been attaching those demons to you for like years. And you've got to work with God to surrender them over one by one. But you'll do it because you're now born again. You're given the Holy Spirit to help you walk in his ways. And that is the narrow path, right? Just following Jesus every day. You know, I've been crucified with Christ. It's no longer I who live, but Christ who lives in me. And the life that I now live in the flesh, I live by faith in the Son of God. One who loved me and gave himself for me. So it's pretty incredible. You know, you just got to keep every day denying your flesh, denying yourself, follow Jesus. And it is as simple as that. Yeah. Jesus came to fulfill the law of the prophets. Yep. And all that's required from us is faith to obey his commands. Yep. Beautifully simple. Yeah, exactly, yeah. Oh. W. Right, welcome back. But yeah. It's the best thing you can do is give your life to Jesus. Like, you know, I heard a story to this guy the other day. He literally like saw The Chosen and he was like a drug addict and he was like, you know, really struggling. Watches The Chosen and realizes, you know, maybe there's something to this Jesus guy. Starts reading his Bible, and within a few weeks, starts reading a Bible that he gets, you know, picks up a Bible, right? And within like I think it was 3 or 6 weeks, his drug addiction completely gone. You know, people's lives just get changed. You know, it's incredible. Right, let's initialize that layer buffer. Right, what's the other thing we need to do? So we've got this layer buffer that we initialize, and then yeah, so we used to do a mesh VB render. This thing, this is our guy. So we change. This is now render layer buffer, right? So we need to add another one of these guys. It will be the layer buffer. So graphics VK command sync. Which Bible do you read? Sorry if it's too personal. No, not at all. Don't worry. You don't have to apologize for asking a question. It's fine. I read the New King James Bible. I got myself a nice leather one with the gold edges on. Nice large text. New King James because New King James uses, so basically King James is the original English Protestant Bible from about the 1600s. I actually have a copy of one of those as well. But obviously it's Old English, not very easy to follow. New King James is sort of like modernized version of that, but some of the words are still a little bit old school, but not all of them. Like and it's quite easy to follow, but there might be a sort of a big word which you're not familiar with. You just have to Google for it, but that happens very little. But they do pop up every now and then. But the reason why I keep to the New King James is because the you know, basically for a long time the uh yeah, so you've got the Catholic Church and the Orthodox split, right? Now I'm not the biggest understander of these things. I don't know know this like all about the history. I'm sort of a new Christian. I'm learning this stuff as I go, right? But basically, like, there's the Catholic documents, like the Codex Sinaiticus and Codex Vaticanus, and then there's the sort of ones from the Orthodox lot, and you find out that in the Orthodox lot, they've got a few Bible verses which have they're not in the and there's a few like words which have been changed. For instance, like First Timothy 3:16. They these things don't completely change the Bible, by the way, but like the thing is when when you see these scribal errors or changes which have been done over time, uh, you yeah, so you see in the NIV it goes, beyond all question, mysteries is which true godliness springs is great. Man, that's reads so horribly. Who uses this version? He appeared in the flesh, right? So if you go to New King James, it actually tells you, right, God explicitly. And yeah. Without controversy, great is the mystery of godliness. God was manifest in the flesh, justified in the spirit. So if you look back in the Catholic line, for some reason it doesn't use the word God in their manuscripts. But if you so they've done a few things. They've taken out like a line in Acts as well, where it basically makes it look like you should be baptized to be saved as well. You got to be careful with those things, but they're minor corruptions. They're not like big old corruptions because you spot big. The thing is you'll spot big corruptions in the text because the all of the scriptures were disseminated like across the world over time, and they could track basically like where the sort of errors or the changes came from effectively. But I trust the non-Catholic stuff more, right? Because Catholicism is is a lot more um yeah, they do a lot more stuff away from the Bible basically, you know. I don't agree with what the Orthodox do exactly either, but I agree with them a lot more, so I trust their sources. Plus, the Orthodox sources come from the actual area of like where the churches in Acts were, basically. It's been the poetic flow of the King James, but it's easy for me to read in modern English. Exactly, yeah. It also fixes some of the translation issues, like how the New King James translated hell incorrectly. Did it translate that hell incorrectly? Oh wait, there's Tartarus, isn't it? Because that's the problem with when you move away from the original Greek, is the word hell is like many different things. You're talking about the one in Peter. Anyway, find it for me and we'll have a look. Um, but yeah, there's so many Bible translations. It's kind of crazy. I remember there's some of them, and it's like, what the, you know, man. Honestly, it's such a bad thing sometimes. I guess it's good to have choice, but sometimes people end up reading the most horrible Bible translations. There's like the Message Bible. There's some horrible ones in that. Oh wow. The Lord's Prayer in the Message Bible. This one. Lord's Prayer, Matthew 5 or something like that, in it. Matthew 6. The MSG, right? You got to stick away from it. It's too much MSG. Um, there you go. So if you read it in like the proper translation, you can go back to the original Greek and you can verify these things, right? But it makes so it's like in this manner, therefore pray. So it's like Jesus teaching themselves how to pray. It says, "Our Father in heaven, hallowed be thy name. Your kingdom come, your will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us for our debts." That means sins, as we forgive others who sin against us, basically. And do not lead us into temptation, but deliver us from the evil one, the devil. For yours is the kingdom and the power and the glory forever. Amen. So the Message Bible, man. Our Father in heaven, reveal who you are, set the world right, do what's best, as above, so below. And I've heard some sort of demonic relations to this, by the way, as well. Keep us alive with 3 square meals. How's that? Hang on, what's going on here? Keep us forgiven with you and forgive others. Keep us safe from the dirt. It's a complete trash. Like, let's read it. Your kingdom come on earth as it is in heaven, right? Set the world right, mate. Do what's best, please. Just where's that? And give us this day our daily bread, right? It's not talking about, just get us our sandwiches, please, God. Right? It's talking like, give us everything we need, provide everything for us, for this day. But 3 square meals. It's a bit specific, right? We're not asking God for 3 square meals. It's horrible. Some of these translations people use. Translated to Hades, Sheol, and Gehenna, and Tartarus. Yeah, yeah. Oh, it does that, does it? That's cool. Yeah, yeah. I've seen the word Hades actually. Yeah, yeah, yeah. Which massively loses the accuracy of what the author was. Yeah, exactly. Yeah, because Tartarus is the whole bottom of hell for those angels, those fallen angels. Yeah, yeah, yeah. Yeah. Those fallen angels. Speaking of fallen angels, I actually picked up the Book of Enoch as well. I actually just started reading it. I've not read it before, but I've heard so many people talk about it that I was like, you know what, my brain's already been exposed to it, so I've just picked it up to read it. And my son decided to draw in it. Just picked up a pen. I was like, you know what, just draw in it. But it's interesting. I'm being careful with these extra biblical things, but it's I'm not going to go too far into the extra biblical, but it's such a you hear about the Nephilim and all this and where they come from, the origins and that. I just picked it up, give it a go. I'm already hearing a lot about it anyway. Um, right, GGFX, BK, scene, player buffer ID. Right, I think we're in a reasonable place now. So, let's see where that goes. Oh. Oh, tons of errors. Right, sort that out. What's going on here? Oh, that's not fun. Not very nice. Yeah, why is it in a V0 though? You shouldn't be doing that. Right, so that in the encoder generator. So VLA in the cogen in the VLA is basic. No, it's not VLA, is it? It's a it's an array. That const expression thing, isn't it? If format version. Yes, so why are we doing that again? If format version. How do we know if we want the sort of whatevers? What is that done again? If a versioning. That's what we want. And that'll help. Ah, shoot. Right, we've got pop in the debugger, I think. And I. Oh, that's not very nice. Did it completely trash my... It's alright. It's in source control, so I don't think I need it. Yeah, okay. That's not very nice, is it? Mm. Yeah, the same problem. Aha. Right, so it does run here. It's got feature flags version. I see, right. So what... Oh, okay, so this was running... Hang on a minute. If version... Let's try that in it. I think that's going to help. I think that's progress. Yeah, looks like it's good. Right, so pixel interlocked extension. Right, so if I go to the fragment shader of the layer buffer, I've got this guy. Oh, it should be called require. I think that's a thing. No. Okay. There's a flat in, of course. Yeah, this should be possible. I don't know why it's not. So right. So what about that? Something weird is going on. Is it not supporting this shader compiler? Because that would be a complete bugger, wouldn't it? Maybe. It was in GLSLC, isn't it? So what about... Is it supported in this? Right, let's keep going. Hang on a minute. Why is that read only? Rewrite, please. Thank you. "17." Right. So I think what's gone on is that I've declared this push constant. Right, define push constants, and that uses, I think that just uses like this layout thing, right? And right, okay, so then I put this thing down, and it's probably like invalidated my push constant thing. Right, I think this has to be declared first. I think. No. Oh, that's wrong. But if I got rid of this, okay, maybe not then. Right, what messed up then? What changed? Oh, you know what? Is the code gen? Yeah, I don't think the code gen ran for this anymore, so that is there. Hmm. Let's run that. What did I do wrong? Did I change something? Right, so yeah, PC instances. Let's just start commenting stuff out. This is weird. Alright, so still has the same problem, but it was working fine before, so interesting. What have we changed? Let's undo that. Alright, let's go to Git. Okay, so anything in the header files which we've changed. So obviously removed all that. Flat in. Nothing really special. But the other one worked fine as well. Oh, what are these? Probably those special new lines, but anyway. Yes, we just renamed it, right? Should be fine. I made it read write instead of read only. Right. That's the problem. Right, I changed the wrong one to read write and I wondered why. Okay. Right, we're back. We're back. Right, forward momentum. Here we go. So, there's no width structure in the push constants, of course. We need a width. So where we make that CPU side. Was it scene dims? Lovely. And the next error is there's a multiply on the line 20. All right, need some recompiles. All right, let's just get back to that in a bit. So, 3. Right, that's getting better. So there was still a visibility buffer image somewhere. Oh. Okay, so this is the attachment info. Right, so for the render pass, we basically want no attachments. And no depth attachment either. That's another interesting take. There will be no depth image, so that means... Yeah, there'll be no depth image. So let's get rid of that as well, because there's now layers. But we might need some kind of depth image later on. Let's just get rid of it though. So oh shoot. Yeah, we kind of need it for like, there's a few things. We need to initialize the buffer with a certain value, and we need to probably resolve a scene depth, I think, for the debug stuff at least. Uh, that's a very good point. Yeah, so the depth here, it could be sampled or it's a depth to stencil attachment, but we want to use it as a storage image now inside the scene shade. But I guess you could do a full screen pass and shading. I don't think you can do storage and depth attachment basically on some GPUs. All right, we're gonna bust. Yeah, so we'll keep the depth image, but we'll bring it back. Right, so for this render pass, we want no attachments. Completely crazy, but it'd be fine. Oh, layer pixel. Cool. Right, so scene shade, we still want the scene layer buffer. And the depth image we don't need anymore. Cool. Now we need to make another shader before we launch and run this. What are you complaining about? Oh yeah. Cool. Right, so that should be everything compiling. Now well, maybe everything compiling, let's see. No. So, hang on. Oh. Right, that's fine. We're still missing the... Yeah, so we've got to sort these vertex shaders and stuff, and then... Right, we should remove the double underscores from the encoder generator. Oh, that's horrible. Because compilers don't like it and they cry. And keep crying and crying and crying. So, we'll just help them out. Cool. Now, what other problem is there? So, yes, just the fragment shader. For some reason, we're failing to, right, graphics shared. Save that. Oh, graphics VK shared encode. Yep. Visibility, but no. Mesh layer buffer. Cool. Right. So let's see what we get. Here we go. So let's actually go to the scene shade just quick. The floors, ambiguous test function under implicit conversion. Oh. Yeah, that was a copy paste thing. They're already in it. They're already in int. Nice. Right, so that problem's solved. The next one would be, yes, this interlocked thing. It requires assignment binding equal 4. No. Why are we getting this error? Do I need like a new version of the compiler? Must it be declared as an in? Oh, it's there. That's what I got. So let's take a look at the extension page. We've definitely got 1.1 or higher. This isn't spivvy though. You have to check the GLSL GitHub usually. Right. Yeah. So we're looking at the layout thing, aren't we? Unordered? Right, I don't think you need the EXT on the end anymore then. Potentially. Right, so we can drop the EXT and that might do it. Oh, it did it. Look, it's gone now. So amazing. Right, so nothing called layer. Hang on. Whoops, that was buggy. Cannot be placed within flow control. Must only be called once. Ah, isn't that a shame? Okay, so basically what you're saying then is if I guess we just do that, make it more branchy. Right, so next thing we need before we run this, we've got some things to fix here. But we want to make sure we clear this layer buffer, right? Because the depth needs to be set to the maximum depth value. If not, none of this is going to work, right? We cannot have it zeroed. So we need to have a clear shader. So let's go ahead and do that quick. Shaders. Always a very simple one. Graphics in it. Guess so. So we'll call it graphics visibility, no, layer buffer clear. Yeah, layer buffer clear. Oh, we've got to do a .cs as well. So hop into the super hard-coded build system. So graphics layer buffer clear. Cool. So in graphics layer buffer clear, basically we can go to the mesh layer buffer render, and we just want to do a very simple thing where we go over all the layers. So read write, please, you know, your layer index. Good point, you need your pixels, such as scene shade. I think we'll do the swizzle thing. Huh. I don't think we'll need a push constants, I think. Get that in there. So it's just a read write, layer buffer, pixel index. Then layer depth is equal to, we could probably do an infinity. And that's all we're looking at doing right over the 4 layers. So we want to do like a layer 0, layer less than that, layer plus 1. Cool. So we just need to kick this guy off. You need a width. You also need just a buffer like that. Cool. So before the mesh render, we would like to do another little compute shader. We want to launch as much as the scene dim, so we probably want to do the scene shade. So that would just be something like, probably some of this actually. I'll be clear. You want your layer buffer read right. You want your width. And then you want to dispatch. Now you probably want to find this. Add. Another compute shader. Layer buffer clear. Cool, so you dispatch over your graphics. Scene dims. Declared right here, what's the problem? Oh, the type's not declared, but it should show up. Oh, did I call it GPU? Silly thing. Okay, good. Now we're in place. So the other error we got was this one. We need to sort out the depth buffer as well on the other side. So speed of the extension was not declared, but one of the following requirements is. So when it creates the graphics pipeline. But we had that, right? We put it in. Did I not? I've daisy chained it, right? Yeah. So they're all. Then you got your. I see. So it gets overwritten. There's an optional one that overwrote it. Cool. Right, so see how broken this is. Oh. Graphics LB, where is it clear? Yes. Right there. I've did it in the wrong one. Okay, here we go. LB clear. Line 6. Yeah, I copied and pasted a GPU one, that's why. Don't know why they didn't recompile, but there we go. Right, 11. Nothing called dims, it's just called width. Oh, no, we need the full dims in there. Because we need an early out. So we need that early out code as well. Fish that out from scene. Shade. Because it's a compute shader, right? Just launches an 8x8, so you can easily. Alright, there we go. Right, most of the way there. Hang on. Why are you complaining? Nah, that's a. Right, .xy. Cool, what's this complaining about now? So, buffer deallocate. Not allocated yet, so that will be on the layer buffer, right? I wonder if we pass in a 0 into here, basically. But then it should. Yeah, max is the size of 1, so that's fine. Hey there, Judy Husk. Working on today, so effectively we've was in the rain marcher with these bricks, right? Was a good. Well, I won't call my drawings good, but here we go. So we have this sort of like cube that we're rendering, and we're trying to we've ray marched into this cube and have a custom material, the procedural material you've been seeing us doing over the few weeks. And so the issue sort of becomes, right, you have a scene, you might have a mesh in the background where it's just got like a bunch of bricks on there or whatever. And then you render like another one on top. And because it's just a cube, it was going in the visibility buffer and therefore just completely overwriting as if this mesh never was behind it, such that when you have these corners, which don't necessarily render any, because it's got rounded corners, um, this just rendered sky pixels in the corner because it was just missing it was ray marching into this mesh which went on top and then wouldn't render the stuff behind. We had this sort of problem with transparency and had another problem where these bricks, like rendering ray marching into these bricks became super expensive when it was a sort of like a grazing angle like this, because basically sometimes you would get like a bunch of near misses with the ray, and it'll be ray marching and taking tons of iterations across here and then ultimately hit nothing. So we want to have a way where we can render at like half the resolution, right? Of, well, not half, but maybe even as far as an eighth, depending on the resolution of the full screen. We want to render probably an eighth, and then a quarter, and then a half, and then a full screen resolution. And we want to do what's known as like a cone tracing. So when we do this sort of ray marching, we want to do it at an eighth resolution, then a quarter, then a half, then full resolution. So that means all the pixels that are going to be ray marching across the same sort of area through the screen, they should that they'll the low resolutions will step most of the way and therefore save a lot of time on the expensive computation during the ray march step basically. Um, but yeah, so we're building a layer to answer the question. To solve both of those problems, we're doing order independent transparency, such that rather than having a single layer visibility buffer, where it just stores a mesh instance index and a triangle index crammed in there with a depth it was a separate render target. Now we've just got a oh, hang on a minute. This is the one. We've got this thing called like a layer buffer. So we're not rendering out to any textures, just a buffer. And a pixel is just a single, it always 4 layers. And it's got this sort of like triangle reference and a depth in there. And essentially what we're doing in the fragment shader is we're using this extension called Pixel Interlocked Unordered, which is supported on all the modern cards apparently. So let's go with that one. And we basically lock the pixel using the hardware, right? So it's done in software, but it's the best version for that hardware. And then iterate backwards over the layers and basically find the layer to insert it while shuffling them across, basically. And yeah, then we'll have basically 4 layers of unshaded pixels, and we can use that to then shade up to 4 layers, but hopefully not. So that should solve our transparency problem. So we don't need a different renderer for transparency. We can still do the deferred transparency render. Sorry, we can still do a deferred renderer and do transparency at the same time. So we can probably put all of our, you sort of merge in the budget for both of them, right? So yeah, we're trying this out, seeing if it will work. Should be fine. Thank you. Well, hopefully, right? And if it works, all praise goes to God because, you know, won't have that without. You know, when you come to think about it, Jesus is the best programmer, right? Made DNA, right? Made made everything. So we all inspired to be like Jesus. There we go. So, this one is when we de-alloc, it says it's not initialized yet, but why? Why? Yeah, I'm confused too. Oh, did we, you know what we did? Well, okay. Mm, yeah, I'm confused. Why did that not work? Right, so let's pop in the debugger. Can't solve it, pop in the debugger, here we go. Radio, pop. So I would assume this is the, let's get up high enough. The buff, the scene layer buffer. It's apparently not allocated yet. Ah. When did you decide that? Because I thought, right, I thought that, hang on. Oh, it's in the initialize. Hang on. So, yeah, but why are you bothering to try and deallocate it? Did it ever get allocated then? We go over all the ah, I see. So, no, I don't see. Oh. One of these is telling a lie. Yes, it's saying if it's not allocated, deallocate it. Huh. Right, so I'm not sure if we've used temporary buffers yet. Okay, let's fix that one. So, what line is that? 3. Yeah, so if it's allocated, then do a deallocate. Ta-da! The worst logic is Boolean logic. It's always easy to get the wrong way around. Right, it's got a white screen. So my color attachment is 0. And this is a problem, apparently. We're not using color attachments and depth attachments. We're just, doing it all manually. So apparently dynamic rendering unused attachments feature allows a way to remove this restriction. Interesting. If the dynamic feature is not used, the render pass bound must be created with, has been created with, hang on a minute. Right. So, we can have 0. I've just not told it be 0 everywhere, I think. So this is in the GPU abstraction, so we should be passing in zeros everywhere. Now, we could get there in the debugger and figure out what's going on, but... Okay, color attachment 1. Why has it done that? Right, let's just get in the debugger there. So right, let's get in there. So yeah, this is the render the layer buffer. So as we can tell, it says we want 0 color attachments, right? So where are you saying I need 1? So all right, something's a bit fishy then. So oh, the pipeline. The pipeline, of course. All right, so so render layer buffer. 1 color attachment, so we get rid of that. Good bad of you. Right. Nothing. Absolutely nothing. That's promising. So what we can do is we can debug this to get it back. And then I think what will be super handy, right, is... Right, so it's taking time to do this. And surprisingly, it takes like 1 millisecond. Which is not very nice. I'm not rendering a lot. So that's a bit skeptical. What's going on there? And then also... What else can I think about for a minute? Yeah, what will be really great. This is an image viewer, but our texture is now inside of a buffer. So it would be really nice if we could register with the image viewer a buffer and say, you know, it's got a custom format and I would like to view it in here. So I have ways to extend this to support sort of super weird and custom formats, right? And then maybe be able to view the different layers within this. So that would be cool because we would need to, you know, all the time we use this thing. So, right, let's easily debug this thing. I just drop in some print statements and also look at its performance because what's going on? Well, actually, we do have full screen renders. I should have taken what the performance was before, but we do have Git. And actually, I didn't commit before. So there's that. We could probably wind back in the tree and compare it, but anyways. It definitely wasn't 1 millisecond for that big of a screen. Anyways, let's go to the layer buffer. Now what's happening is so yeah, it's doing lots of write operations actually. Yeah, so for lots of empty pixels, it probably just goes over this. We'll see what's going on. Now, what are we trying to do? Yeah, so we're trying to figure out why doesn't this actually render. So if is mouse at record. Then we want to basically just say, you know, print out that for me, please. So can we just start there and see if that helps? Right, so we're getting something, yeah? We're getting depth. Now, next thing to figure out is... Oh. So we'd like to kind of see how some of this works. So because it's interlocked, now the print should come out evenly, right? So we should be able to print out like, here's a layer. So, and then we will also want to print out like, oh, this should have broke. This should say break. That's true. Right, so it's doing your sort of 2 1s and 0s. Now, yep. So we want to basically say, so this will print out a 1, and this will print out a 0. Do the other way around. So if it's just, yeah, it'll print for this 0x2, it's going to print out a 1 to say that it's stopped, basically, right? It's reached the end. Okay, so right, so all of them are the same, basically. So your 1s are the layer index, right? So your layer index, here's the first one, right? So 2, it just does a move, right? A shift right. Then you layer 1, shift right, layer 0, a shift right. So nothing ever says it writes it out, which is a shame. So, all right, yeah. So you've got to layer 0. Yeah, so it never actually writes out the final value. So just keep shifting it. So you want to say, yeah, I think what you want to do is probably find the layer to do the insert at this point. Yeah, so you do something like that. Find the layer. You know what? You don't have to. You know what? Just remove the comments, I think. Yeah. Okay, no, let's just put it all here. So only check the final layer. Reverse search for the where to insert while shifting the layers to the right. Something like that, yeah. So you want to find your layer. It's just a while basically, right? Nice. And then you basically just get rid of that. Get rid of all the fluff for a minute. So you're basically saying shift if greater than, then break. Now insert. I think that's what we're looking for. Right, we obviously didn't get that compiling. So because it's missing an equals. And voila, we're back. Cool. So what's the performance on that? Right, it's still kind of... Hey, I thought I'd fix this bug. Maybe I didn't. Not very nice. Oh, I fixed a different one then. No, 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 no. Theme post process. Do, 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 do. Right, I didn't fix that bug then. That's a shame. Alright, I need to look at that again off stream. No worries. Just crashes every now and then when you resize. No biggie. Right, so it's about this sort of height, which was about 2 milliseconds to render basically. Now, it's now taken like 2 milliseconds to render the scene out into this visibility buffer layer. It's expensive. So what are we doing which is causing it to be that expensive? Oh. So we're doing lots of these sort of like read-write layers, right? Maybe the better idea might be like, hey, copy out the full thing and write it back, maybe. Right. Let's see what the performance is on that. So if we were to say, get rid of this, how well does it perform, right? Well, clearly it just runs instantly, and I guess they've compiled it out, haven't they? Yeah, let's say it just writes to layer 0 something. Let's say read write layer 0 dot depth equal 1. I don't know. Just do something like that, see what happens. What does it do? Yeah, but how does that even still work? I guess it's left it in the visibility buffer such that it still renders. That still costs 2 milliseconds. Why does it cost so much? If I got rid of this interlocked stuff... See, maybe it was already costing that much anyway. I'm confused now. Like, you know what? So, what we're going to do is do that, right? Write out a single value to the storage buffer and just see what happens. So we're going to close it down. All right, here we go. So we're writing out a single value. Oh, hang on. Yeah, so I reckon because we're using a visibility buffer before, and it was doing it to a texture, it might be quicker, right? But then I didn't think it'd be... Yeah, so even when you just write a single value out, it's kind of... Right, so I guess the thing to check will be that to stash our changes. I've added files. Right, let's commit this for a minute. Because we've got it working, right? So git commit dash a so add layer buffer first draft of your, just add the layer buffer, first bit of layer buffer code, maybe. Something like that. Done. So now you're gonna do like a git. I always forget this, right? How do we go git reset, isn't it? Head up. What day are we? Are we on day 20 what? Day 23. Let's tag it just in case. Undo. Ah, it's so damn confusing. So we want to go keep changes, stage your changes. I think we'll do that. So git reset soft. Wait, it moves changes back to your working directory. The changes still there. They're added. Hmm. This permanently deletes it. No thanks. Does it really? I think that feels wrong. Man, I hate Git. Right, where are we at now? I knew I'd put it in there. The soft did. Do we still have that commit? Right, this is where you do the super lovely backup your whole directory because Git's horrible. Git is, as you know, it's in the name. Sort out. Right, I would like to. Right, so git reset is hard. Right, I moved a bit. Ah, no, don't do that. We want to go to day 22 minute. Git reset to tag. Right, I think we're basically there. And all this stuff is in the status though, is that? Right. Anyway, we'll leave that here. So we want to run this. Right, here's the old one. So the cost of this, we can barely see it, right? Doing a visibility buffer. Oh, it barely scratches the surface, doesn't it? So using a shader, sorry, using a storage buffer inside the fragment shader seems to be like real slow. No matter if you're doing like real bad, real slow. Yeah, so looking to anyway, so let's revert back. So we've seen the performance there, you know, and if we resize the screen, let's just see quickly how that impacts. Right, let's resize the screen. Something like that. It's right there, right? It's like a 0.16. Right, so super cheap. Super cheap. Now, let's figure out to get our way back. So git reset day 30 or day 23. What are these doing here? Right, let's get rid of those files. Right, I think we just successfully did git. Always the most scary thing trying to get. Right, so it seems like the performance ain't too good. But there might be ways around it. We just got to investigate. See what's going on. So right into a storage buffer is not probably going to work. So we might have to do some other ways. We could have 4 different textures, but then if we multiply it, so like here's the thing, right? Our texture is 4 times the size as well. That's what you got to be thinking about. So this is rather than 0.07, it's now 0.8. So it's basically 10 times. Then if we went, oh, it really doesn't like it when there's more things. Right, so we did it like this. Now it's gone up to 2 milliseconds rather than 0.16 milliseconds. So yes, it's like over, it's like 12 times slower. Now, question is why? Because we run out to a storage buffer, and we even got rid of all this interlock stuff, and it, so that's interesting. I didn't realize writing out to a storage buffer is so bad, but it might be because it's writing out to. Now here's the thing, right? It's not swizzled, so we might not be getting any cache. Might not be very cache friendly. There is that. I wonder if there's ways we could pack it down better, right? And write it back out again. That could work. I think this could be part of the issue, but this is like real bad. So we can play about with just changing it's about 2 milliseconds right now, okay? So we could try Morton Swizzle it. That's an option. So yes, I think it's a cache thing. Let's see if the AI has a thing that could help us with it. But I think it's cache and maybe the swizzling, right? Because it's all swizzled in, typically in textures. So why could write into a storage buffer instead of a render target in a fragment shader be like 10 times slower? Let's see. Yeah, that does make sense. But so compression sometimes that's true. There is an early depth test as well that we would have probably got. Early depth, right? But we haven't got many triangles as well. So bypass L2. Right. In the Python barrier stalls. So yeah, there's the early Z. We was getting early Z because we wasn't writing to it, yeah. And also our depth buffer used to be 16 bits, but I changed it to 32. So yeah, so those are probably your things, right? Some more memory. I wonder what happens if we pack it down anymore. Yeah, say if we packed it down to 16 bits, would that play a factor into it? Yeah, so we've got, yeah, 8 bytes, it's 32 bytes per pixel, so it's quite big. Yeah, it'd be 128 bits, wouldn't it? I think that's right. Oh, sorry, 256 bits, right? So that'll be, yeah, 32 to 64 bits. Hang on. No. So there's U32 and a F32, so 64 times 64 bits times 4 layers, 256, yeah. So in the previous one, it would have been a 32 plus a 16, and that was it. So it would have been only 48 bits. So there's a lot more data being transferred as well. So I think what we want to try and do as well is avoid. We're doing a lot of writing as well, maybe. But by doing it from back to front, we're constantly, every pixel is going to be doing shifting, shifting, shifting. And then it finally writes it out. Right? So maybe, yeah. So you probably only want to do this behavior when your thing is full. But if your thing has some empty pixels in it, you probably want to just find the empty one and write it in. Right? So there's that sort of thing as well. Yeah, this is going to be constantly trying to shift. Yeah, so we could write this better, I think. Yeah, write this code a bit better. Maybe see if we can reduce how many of the layers that we touch. You know what we could do actually is yeah, make them out of order and reorder them in the scene shade later on. So your objective, so rather than shifting stuff and moving everywhere, yeah. But then again, I remember we took all of this out and we only wrote like one value and it was still slow. So I don't necessarily think this is going to matter that much. Wait, yeah, we hardcoded it once to one value and it was still, let's try that again. So if we just say depth equal 1 on every pixel, let's get rid of the interlock stuff and just write it out. So it's not got any cache locality. Let's just get rid of the interlocked, right? And that gets you, hang on, layer 0. So yeah, it's basically not changed. That extra logic was adding like no, oh, I forgot that every time. Yeah. So it's probably 100% to do with like the amount of data we're pushing out every frame, or the The fact we're not getting the early depth. Yeah. It's basically the same. Cool. So you was getting like an early Z rejecting thing going on as well. This is a very simple shader. Okay, this is good to know. This is probably fine. It probably works all right. So we used to get early Z. Why are we getting this as well? This shouldn't be in there anymore. Probably didn't. Yeah, it didn't contribute anyway. So yeah, so now it's got to find time and launch a pixel shader, which then tells it whether or not it could be rejected. Whereas before it would just do it in the depth buffer. So that probably contributes to something. But also probably, yes, here's the next thing, right? Let's just, it's very simple, reduce the number of layers. Let's just go into here and change this to 1. Or 2. Let's change it to 2 because that might work better. So, does that... Hang on. I've got to recompile the shaders. So scene shade, and then that one. Build system didn't catch that, unfortunately. Interesting. So this has reduced it down to 0.18. So that is 2 times as slow as it was in the original one. So the original visibility buffer. So that's very interesting. So we do this sort of window size. So that went to about 0.16 in the other one. So this is looking at like just over 2 times in this case, but maybe the window size is not exactly right, and therefore ends up being 2 times. Okay, so yeah, it's probably 2 times. So what we're seeing then is some clear things to do with the cache. Yeah, so right now textures and storage buffers would be basically the same. It's just so here we're writing at 2 times the amount of data, at least, because that was 64 bits times 2, basically 128, but then before it was 48. Right, so we're seeing like a 2 times slowdown because it's no longer super lightweight, it's now more expensive. So rather interesting. So it seems like the solution is to somehow make this go smaller, because that's quite expensive. But this is already kind of quite small. So the depth is an interesting guy, right? So depth, the thing is about depth is what you kind of want. Like you think an F32 is too big, right? Maybe what you want to do is relative depth. So you basically, say, well, from this point, I'm this much forward, right? So you can maybe compress it a bit more, but so having 4 of these alone, these instance references, they're E32, having 4 of those alone gets you to 128. Right, and that already is going to increase it by 2 times. And then you'll have the depth in there as well. If we was fair to the original one, we was using a U16 for the depth. So you could maybe normalize that down into like a U16, right, and pack 4 depths. So yeah, we could do that. Yeah, and then maybe we can compress these guys down even more. So what we might do is bring out full U64 stuff, but we don't have U64 in my encoder gen. So we might be able to bring that in, or maybe we'll just bring it out of this system for now. So if we did, let's just play around with it. So if we did a U64, you might be able to pack in. What do you want to do? So 65k instances is probably too many. You could, no, sorry, 64k. You could probably half that a few times. So 32k, 16k, right? 8k, no, 496, right? 4,000 instances, probably fine. So you can squish that right down. 12 bits. And then like a triangle ID. I don't know, we'll probably be doing clusters at some point. So you want to find, I think we'll do clusters and then a triangle. But yeah, 65,000 triangles. Yeah, so you break it down into like clusters and then a triangle. So the triangle index would be, what would it be if we broke it down? So your triangles will probably go up to like 64. So that's like how many bits? That's 6 bits, isn't it? So 6 bits for a triangle, and then maybe 10 would be 1,000 clusters. Yeah, so I think maybe 16 bits is probably fair. That potentially. So if you add that up, that's 38, isn't it? It's getting late. My brain. 28. Right, so yeah, so 28. Then we got, say we did 16 bits for the depth. That's 44. So yeah. But I wonder if you can do some sort of like different packing system where you basically just pack all of the ones next to each other. Like maybe you pack like 312s is, yeah. But then 412s would be 48. And then you can get a 16 in there, is that right? Yeah, so you can pack 4 of your instances together, and then you can pack a triangle ID on the end, right? Um, so maybe you can do something like this where it's a little bit more of a funny packed thing, but it means it's really squished down. But it'll be quite tight. But that's already 64 bits. And then for depth, you probably want to make them. Yeah, I reckon you could. Yeah, Yeah, so for depth, you probably want to have like 24 bits. So the great thing about this encoder gen, actually, you can pack them all. They don't have to be exactly lined to the word boundary, and it does all the unpacking automatically. So we could just be just do it as made up of U32s, and it should work. So 24-bit, if we did a 24-bit depth, that would be 72. But then, yeah, if we did a 20-bit depth, maybe. Or we could just make it 16. Yeah, 20-bit would do, obviously, 80. A lot. It's a lot of bits. I wonder if you can do something special where, like, we need a depth value for each one that gets a hit. Yes, so the other approach we could have taken is the linked list. Maybe that's the other thing we do, because having this sort of max allocation is a bit crazy in terms of the amount of stuff you're writing out. But if we did a linked list, we could max allocate enough room for everything. But then you got the linked list problem. Um, um, yeah, but the issue was, even if we wrote out one value, it was still really slow because it was writing to many different places in memory, wasn't it? So you want to write, well, it wasn't, it was writing to many different places in memory. Maybe it was writing too much memory. Yeah, that might be the problem. Maybe it's writing too much memory and therefore it's hitting some threshold in the hardware. So therefore it has to do more work, if you will. Yeah. So maybe the linked list approach could work, although I hate a linked list because it spends, you've got to waste bytes to say this is where the next node is. And this is why I wanted to max allocate bits, because you could just, So what we could do is say, no. I wonder if you could store out just the triangles. No, you can't. You need the depth there. You can't recompute that. Because the depth is very... The depth, if you could maybe make that... You have the option for a variable encoding. That's possible. So you could variably encode depth. And that could be relative from the previous one. That might be an option. So you could do 1, 2, 3, and then a 16, and that'll be 160. That'd be 164 basically. Yeah. Then you could do that. And that will be 48. Very sorry. 48. So it's got a 64 plus a 48 already. So you've only got another 16 to get to 128 bits, and that's probably where you want to max it out, you see. You know what it might be then? Right, maybe we're doing it all wrong. Maybe we should have them layered. Yeah, I think I've got some ideas. Maybe what you want to do is render the front layer first if you can do it. And then that would be interesting. Yeah, because the problem is you're not right into the same. No, 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 no. Yeah, so that's what it could be. There could be two problems, right? Either we're writing out too much memory and therefore we're hitting some limit. Some limit in hardware. Or when we write out, there's too much. It's not near each other in memory, so it's not able to write. Yeah, so maybe there's like a locality thing. Locality, as I spell it. There's like a memory. No, not being together as everything is too far apart, right? These are my two leading theories on where a lot of the performance is going. Like, so if you're writing out, there's a bit of a it used to be 48 bits, right? So if we're writing out now 256 bits, right? You would expect 5 times slower, at least, because that's you're running out 5 times as much memory. So if it was 0.16, times it by 5.3, sorry, 0.16, you'd expect it to take 0.8 milliseconds, but it wasn't. It was taking 2. So there's some extra stuff at play here, right? So if we're hitting, yeah, so I wonder if there's anything to do with like, so you render a bunch of triangles and the neighboring pixels could all write out as part of the wave, if you will. They will write out into the first layer of the layer buffer, right? And then the ones, yeah, so maybe we should be spacing the layers. So it should be, yeah, so maybe we shouldn't store the layers as an array like this of pixel. Instead, maybe it might be better to shuffle. Yeah, so maybe just call it the layer buffer pixel. And there's probably a bunch of, yeah, and every time you up the layer, it's offset by another width times height. And that might be the way to go. Right, we'll try these ideas out next time. Let's write them down. So try out layer stride. All the pixels in on the same layer next to each other. What else? The other idea was on the same layer next to each other. That's a good one. Hmm. I'll think about the rest. Yeah, there's something to think about at least. Awesome. Right, thank you so much for coming, guys. There's a Discord if you can come and chat in the meantime. And yeah, if you guys want to support the stream, you can get access to the code and run it in your own local machine. There's more details there, and support the channel as well. Thank you for everyone who's supporting the channel. Appreciate you all. The next stream will be on Tuesday at 7:30 p.m. GMT. Yeah, that's right for the next week or so, isn't it? Yep. So Thursday as well, the same time, and then on Friday as well, a stream in the afternoons about 2. And obviously on Sundays as well, which is today. So yeah, thank you so much for coming, everyone. I appreciate you all. I'll see you all hopefully on Tuesday. And yeah, we'll try and solve this very interesting problem. But right, catch you all in the next one. Bye bye. Have a good start to your work week. God bless you all.